Hey there, science fans, have you ever looked around and wondered what everything is made of? Well, you're thinking about matter. Matter is anything that takes up space and has weight. Your phone, your shoes, even the air we breathe, it's all matter. Now let's zoom in really close, way smaller than even the tiniest ant. Eventually we get down to the basic building blocks of matter, atoms. Atoms are incredibly small, but don't let their size fool you. They are the tiny titans holding everything together. Imagine a giant Lego castle. It's built from countless small Lego blocks, right? Well, matter is a lot like that castle, and the atoms are like the individual Legos. Everything around us is constructed from these tiny particles. Just like different Legos can be combined to build amazing things, atoms can combine in different ways to create all the different types of matter in the universe. Pretty cool, right? Now let's delve deeper into the fascinating world of atoms and explore their secrets. We know that atoms are the building blocks of matter, but they don't like to be alone. Atoms love to team up and form different combinations. Sometimes they join with atoms of the same kind, and other times they link up with different types of atoms. When atoms of the same kind stick together, they form elements. Think of elements like the ingredients in your favorite recipe. You have your basic ingredients like flour, sugar, and eggs, right? Elements are similar. Some common elements are oxygen, which we breathe, and gold, which is shiny and valuable. But things get even more interesting when atoms of different kinds decide to mingle. When atoms of different elements combine, they create something called compounds. These compounds are entirely new substances with their own unique properties. Think about table salt. It's a compound made from the elements sodium and chlorine. Sodium on its own is a metal, and chlorine is a gas, but together they make something safe and tasty. Compounds are proof that when atoms work together, they can create amazing things. Okay, science explorers, we've learned that atoms are tiny but mighty. Now, let's put on our imaginary shrinking suits and dive right into the center of an atom. What we find might surprise you. At the heart of every atom lies the nucleus. Don't let the name fool you. It's not like the nucleus of a cell. The nucleus of an atom is incredibly dense and tiny, but it contains most of the atom's mass. Think of it like a tiny marble at the center of a giant soccer field, but the atom is not just a solid chunk of stuff. Surrounding the nucleus is a cloud of even tinier particles called electrons. These electrons are constantly buzzing around the nucleus, like planets orbiting the sun. The region where electrons zip around is called the electron cloud or electron shells. These shells are like energy levels within the atom. And guess what? The way these electrons are arranged in their shells determines how the atom interacts with other atoms and forms those amazing elements and compounds we talked about. Section 4. Subatomic particles, protons, neutrons, and electrons. Now, let's meet the amazing subatomic particles that call the atom home. We've already met the electrons, those tiny particles whizzing around the nucleus. But what about the nucleus itself? What's inside that tiny marble at the center of the atom? Well, the nucleus is home to two important particles, protons and neutrons. Protons are like the atom's tiny positive charges. You can think of them as the optimistic particles. Each proton carries a single positive charge. Neutrons, on the other hand, are neutral, meaning they have no charge. They are the peacekeepers of the atom. Think of it like this. Protons and neutrons are huddled together in the nucleus like friends in a huddle. They give the atom its mass. Meanwhile, the tiny electrons are like energetic bees buzzing around the huddle, carrying negative charges. The number of protons in an atom is super important. It determines what element the atom is. For example, all carbon atoms have 6 protons, while all oxygen atoms have 8. The number of protons is like the atom's fingerprint, making it unique. Section 5. Atomic models through time. From simple spheres to quantum clouds. Our understanding of the atom has evolved over time, thanks to the brilliant minds of many scientists. Early on, people believed that atoms were indivisible spheres like tiny marbles. This was the idea proposed by John Dalton, and it was a good starting point. Then came J.J. Thomson, who discovered the electron. His model imagined the atom as a positively charged plum pudding with negatively charged electrons scattered throughout, like plums in a pudding. It was a delicious analogy. But the story didn't end there. Ernest Rutherford came along and through his experiments discovered that the atom is mostly empty space, with a tiny dense nucleus at its center. He proposed a model where electrons orbit the nucleus like planets around the sun. Niels Bohr refined Rutherford's model by suggesting that electrons occupy specific energy levels, like rungs on a ladder. Finally, we arrived at the quantum mechanical model, which describes electrons not as tiny planets, but as clouds of probability. Talk about a wild ride. From simple spheres to quantum clouds, our understanding of the atom has come a long way. And with each new discovery, we unlock more secrets of the universe and gain a deeper appreciation for the incredible tiny world within.